Welcome back, students. In this section, we'll try to understand all about the correlation analysis. When I'm talking about the correlation analysis, starting from the concept of correlation, what does this mean, and also the approaches how we can solve the correlation, and so on and so forth. And practical problems, we'll be taking some practical problems, and we'll try to solve so that entire theoretical concept we can grab it very quickly. Now, before I go ahead about the correlation analysis, what are the methods of doing that analysis, and a few examples on that, let us explain what exactly the concept of correlation. Now, if I ask you that, think that you are the college students, and definitely there are so many subjects which you need to cover, right? Like starting from mathematics, maybe the economics, accountancy, biology, physical science, and so on and so forth, geography, history, and so on and so forth. Okay, as per your the stream and all. Now, if I ask you, let's take an example that you are having several subjects to cover in exam, and you are having two main papers, like I say, the mathematics and also the economics. Now, if I ask you that a student, if he or she is good in mathematics, will he or she score good in economics? If I ask you this question, what will be your answer? When I asked my students, okay, my students, maximum students, they were clueless. They were really clueless. They didn't try to find out is there any kind of relationship, okay, whether some student is good at mathematics, whether he will score good in economics also or not, or he will score good in accountancy or not. Now that is the challenge. Now, second question, if I ask you, I'm 100% sure you'll be able to answer. Now, second example, let's take an example that I am asking that is there any relationship in between the greenery in this entire world on earth and the temperature or the global temperature? Think. I'm saying that measurement of greenery, let's say number of trees, whatever we are having in this world, and the global temperature, whatever we are having currently. Is there any relationship? Definitely all of you will agree with me that if greenery increases, then temperature will decrease. More and more greenery we are having in the ecosystem, we will have the lesser temperature, right? It will not go towards the global warming, right? That is a common fact which everybody knows that. Now, first question or first example, whatever scenario I asked, you had no clue, but second question or the second scenario, you have the clue. Now, this is nothing but the correlation in between the greenery, and correlation in between greenery and the global temperature. Surprised? Let's take another example. Now, think that nowadays a lot of COVID cases are coming. COVID pandemic is there across the globe. Now, in that case, if I ask you, is there any relationship of death, COVID death, along the one way as a variable, and is there any relationship with the age of that particular person? Then you may say that, let's say, okay, 0 to 10 years death rate is high, 50 to 60 years death rate is high. It may be possible in between 10 to 50 the death rate is not that much of high, right? And it is proven nowadays. Now what happens? We are trying to understand in between two variables, the relationship in between two variables. What are those two variables? In this case, the death rate, number of deaths, and on the other hand, another variable is the age. Similarly, greenery versus global temperature. Similarly, mathematics score marks versus the economics marks. Now, here in all of those three cases, we try to understand the relationship in between these two variables. How, if someone is going high, what will be which variable will go down, or the second variable will go high or not. Now, this is the concept of correlation, and in this section, we'll try to understand how we can measure that. Now, the second question comes into the picture, that can we do the measurement of this? The answer is yes. But before that, let me explain you few features of correlation analysis. It is to establish the relation between two variables, we use correlation analysis. Now, the moment I am saying two variables means bivariate, x and y. Let's say greenery versus temperature. Let's say age versus death. Two variables we are trying to understand the relationship. It is always called the bivariate analysis. Now the question is it only two variable? The answer is no. In generally in syllabus, till I will say the master's degree, we take care of these two variables and all. And in PhDs and doctorate and the researches, we use more than one variable. Okay, we deal with maybe more than 50-60 variables when we try to understand certain relationship. In that case, we call about independent variable and the dependent variable. In this case also, let's say I will say the temperature, which will be the dependent variable, and the I will say the greenery will be the independent variable, right? If I try to understand what will be the temperature if greenery goes up and down, right? In that case, temperature is the dependent variable and the greenery will be the independent variable. In another example, like the marks of mathematics and the marks of economics, in that case you can see the vice versa, which one you want to measure, which score is depending on which score, correct? So in this case, herein we will talk about all the cases. In this section we'll be talking about considering only the two variables, and that is nothing but it is called the bivariate correlationship analysis. Second point which I would like to say, that the coefficient of correlation, that means in short we represent it by rho or r, small r, rho letter or the r letter, coefficient of correlation. It only determines the whether the given two variables are related or not, and if it is related, how strongly it is related. Okay, weakly related, positively related, negatively related, strongly related, or there is no correlation in between them. So we can only understand that what will be the correlation in between them and what is the strength of that, but it does not show any causality, or it does not say any kind of cause and effect behind this relationship, and that we need to understand. And this case, when we need to understand the cause and effect, then we need to do the regression analysis. Now hope you have understood the base of correlation analysis. In correlation analysis, we'll try to understand the relationship. If it is existing, then how strong it is existing, that's it. And the reason why, that we'll try to understand in regression analysis. Now the question was whether we could calculate this relationship or not. Definitely we could calculate, and that is the main crux in this particular section. Okay, so there are four different methods to calculate or understand the relationship in between two variables or the multiple variables. One is scattered diagram. So that means in this section we'll try to understand, we'll consider the x-axis and the y-axis, or rather x-axis and y-axis, and we'll try to understand, we'll try to plot the variable values. Okay, and we'll try to understand and try to fit the best fit line and try to understand how this diagram looks like, whether it is more than 0, less than 0, or whatsoever equals to 0, whether there is any relationship, positive relationship or negative relationship. Second method, all we talk about the Curl-Pearson's product moment coefficient correlation. Now this method is only applicable for the parametric test. Now this is the basic importance of this requirement of this particular formula, or I will say Curl-Pearson's product moment. We need to remember this is only for the parametric test. Now what is the parametric test? The parameters is nothing but when we are getting a certain data and we can calculate mean, median, mode, standard deviation, variation, and so on and so forth. The moment we can do that, then we can use the Curl-Pearson's product moment correlation coefficient. Clear? Now let's take an example, as I gave the example that number of greenery means number of trees and the temperature. So these are the parameters. We can take the average, mean, median, mode of the temperature, and also we can take the mean, median, mode, standard deviation, variation of the number of trees, right? So in that case, we can use this Curl-Pearson's product moment coefficient formula to find out the relationship and how it is strongly related, right? But the moment I talk about non-parametric test, right? Let's say we cannot calculate the mean, median, mode and all. We cannot handle the parameters, right? Now you can ask me what is the example. Let's say the beauty. okay, smartness, intelligence, we cannot measure in that way, right? We cannot get the mean, median, mode, and so on and so forth. In those cases, we will use the Spearman's coefficient of rank correlation concept. We will discuss in detail all of those 3 and 4 methods in subsequent lectures. And the final one is coefficient of concurrent deviation. Now this is the important understanding, that when we will try to understand and use this concurrent deviation method. Now think that I want to know only, I am not bothered about the magnitude of the relationship, right? I only wanted to know whether it is positively related or whether it is negatively related. That's it. I don't care whether it is zero point 0.7 is the correlation or zero point 0.5 is the correlation. So in that case, those cases, we will try to use this kind of concept of the analysis, which is concurrent deviation. Now if you tell me the example, if you want me to give an example, let's say that you are doing certain analysis in your company, and your company wants to invest in coal mines, or let's say steel plants, right? But you need to understand whether what was the history of this steel demand versus price. Okay, in that case what happens, let's take an example. You want to know what was the relationship in between steel quantity demand, okay, and the price in between, let's say 2001 to 2010, and you are not bothered about whether it is strongly related or how strongly related. You are not aware, or you do not want to understand the magnitude, that means quantitative, particular specific number like 0 0.7, 0 0.72, 0.75, 0.8 and all. You are okay to understand whether it was a positive correlation or the negative correlation, and to some extent, let's say even if it is 0.7 and you are getting the answer of 0.6, you are okay. Okay, that does not affect your calculation and all. In those cases, if you want, then we will use the coefficient of concurrent deviation. Hope you have understood all these 4 methods, and definitely we are going to explain in detail in the subsequent lectures. Now before I move ahead, okay, I talk about some history about the correlation, and I talk about something that Carl Pearson and Spearman's life and so on and so forth. What is the value of correlation? I'm talking about the correlation, coefficient of correlation and all. Herein in this section, we have represented the coefficient of correlation by R. But in normal cases also, you can use the rho, this letter, to represent the value of coefficient correlation. And this is nothing but it is in between -1 to +1. That means it may be -1, -0.5, -0.25, 0, 1, whatsoever. Okay, in between -1 to 1, this range, this coefficient of correlation value will be there, irrespective of the type of I will say the method you are using, whether it is parametric test, non-parametric test, whether you are using concurrent deviation method, Carl-Pearson method, Spearman method, or the scatter diagram, whatever the method, irrespective of the method, the value of coefficient of correlation will be in between -1 to +1. Now here the most important things come into the picture. Now let's take an example that it is in between -1 to +1, and this is 0. If I draw this number line, now I am going to explain you that based on the value we can decide how strongly it is related. Okay, now it means that it may be 0, it may be -1, +1, and so on and so forth. The moment I am saying that this is the negative side and this is the positive side, I will say 0, less than 0 to till -1, this is negative correlation, and this is positive correlation values. Clear? That means if I get, let's say 0.5, I will say it is positively correlated in between these two variables. If I get -0.75, I will say it is negatively correlated. But how strong? How will I define that? What is the strength of this relationship? For that, we are going to divide this entire number line into different parts. Let's say this is 0.9, that means plus 0.9, and this is minus 0.9, 0.75, 0.5. I'm just talking about minus minus, minus 0.25 and 0. Similarly here 0.75, 0.5, 0.25, all are plus and 0. Okay, hope you have understood in this number line what I'm going to do. Now the moment you are getting the value after using the formula and any of the methods, okay, if you are getting the value of plus 1 and the minus 1, okay, then I will say it is perfect positive correlation and it is perfect negative correlation. Perfect means it has perfect minus 1 value or the perfect plus 1 value. And if you are getting the value of 0, I will say there is no correlation existing. That means if I am getting the value of r equals to 0 in the greenery after applying the formula and the concept of correlation analysis, I am getting the value r equals to 0 for a relationship in between the greenery and the temperature, then I will say look, there is no relationship in between them, right? So that is the conclusion. Now if I am getting 0.25 and all, I will say very low correlation, is existing, very low positive correlation or very low negative correlation. The moment I am getting zero point 0.5, close to 0.5 value, plus 0.5 or minus 0.5, I will say it has moderate negative correlation and it has moderate positive correlation. Moderate positive correlation. Moderate positive correlation. Now this basically it happens minus 0.5 to 0.75. okay, I say it is moderate, or if it is less than 0.5 I will say very low coefficients, right? Like this only. Is it clear? Now the moment I get 0.9 this value, I will say it is fairly high negative correlation, fairly high positive correlation. So that means the moment I am getting the value is 0.9 or close to 0.9, I will say it has a very fairly high positive correlation on the negative correlation. Clear? Now the moment I am getting any value in between 0.91 to plus 1 or minus 0.91 to minus 1, in this range I will say it has very high positive correlation, very high negative correlation. Now this gives an important idea how we can interpret the result and measure the strength of these two variables or strength of the relationship in between two variables. Like now here in this case, the important thing which I need to explain you, in a lot of research in PhDs and the projects, we get the value in between this 0.9 to plus 1. So basically it is called very high positive correlation or very high negative correlation. But in research we say this is not a very good idea or the relationship. The reason is the moment we are getting any value more than, not equals to, more than 0.9 plus minus, then I say there must be existing some sort of multi-collinearity. Now what is multi-collinearity? It means there may be the effect of multiple other variables on the dependent variable. Okay, is it clear? It means that only to get the value of y, only x is not x is not responsible. There are some other variables which are overlapping, which has strong relationship in between that, so that you are getting more than 0.9 value of r. and this phenomena is called multicollinearity. And in research and any cases, this is not a good phenomena, and in that case we try to understand which are the variables, let's say x1, x2, x3, these are strongly related, and we need to eliminate one by one those variables if it is more than one, and we will find out only one variable which has correct relationship with the dependent variable. Now this is a very very important concept in relationship or the correlation analysis. But somehow, you know, if you consider or if you refer different books and papers, journals and all, then you will say these are the different types of, you know, parameters or different types of segments, bifurcations in between -1 to +1. This range, what we call, whether it is a moderately positively correlated or very high, fairly highly correlated, negatively or positively, or whether it is a perfect positive correlation or the perfect negative correlation, or at all they don't have, or the variables do not have any kind of relationship if you are getting the value of r equals to 0. This gives a very very important idea about the correlation analysis and the value of coefficient correlations. Before we move ahead, let's see for a moment that who were this Carl Pearson and the Charles Spearman who invented basically these formulas and gave a path breaking, you know, idea to measure the relationship. Now Carl Pearson, basically he was the FRAC, and he was an English mathematician and biostatistician. He has been credited with establishing the discipline of mathematics, statistics, and so on and so forth. You can refer the Wikipedia for that. He was born in 1857 and died in 1936 in UK. He is famous and he is known for principle of component analysis. This principle of component analysis we use in factor analysis in our research, okay, or data analysis. We use a principle of component analysis, Pearson distribution, and so on and so forth. So this is the brief about the Carl Pearson. You can go to Wikipedia and you can search all about his life, history, and the work. You will get it. Now another gentleman, Charles Pearson, basically he's the English psychologist. His full name is Edward Spearman, FRS. He was an English psychologist, as I said. His work, you know, he's known for the statistics. His work mean as a pioneer of a factor analysis. Now, factor analysis means nothing but, I'm again and again this word is coming. Let me explain you what is the factor analysis. When we try to understand the effect of different independent variables on a latent variable, okay, and out of all thousand of variables, we cancel out or try to find out the relationship, and we bifurcate them into different factors, few factors, then we do the factor analysis, or we call it the factor analysis. In short, let's take an example. We want to do the what I say that psychological test, okay, and I try to understand what is your personality. So your personality may be aggressive, it may be the introvert, extrovert, and so on and so forth. So if you try to, you know, jot down a lot of you know, psychological characters, you will find more than 200, 300, maybe thousands of characters you are having in a human being. So out of those 1,000 characters of the variables, if you try to find out some you know, some main I will say factors, or the dependents or independent variables, or the which are forming a specific factors which leads to you know, help us to form a proper character, whether you are introvert, extrovert, and so on and so forth. In that case, we do the factor analysis, and later on we can discuss in detail in factor analysis, Amos, SPSS, and so on and so forth. That's a different thing. And the Spearman's rank correlation coefficient, he is the major contributor, and he invented that particular method. He was born in 1863 and died in 1945. So both of them are, you know, the same age basically. You know, Carl Pearson was born in 1857 and Spearman was born in 1863. Hardly 6 years here and there, right? And the death also hardly 9 years here and there. He was as a nationality, he was an Englishman, and he was definitely the FRS, Fellow of Royal Society. You can do the Google, you can understand all of these biographies or the stories about Carl Pearson and the Charles Spearman. Hope you have understood and you enjoyed this section. See you in the next section.